Hey, listeners. Fred's off for the next couple of weeks, so we have a couple short episodes that we recorded with Phil Koopman. These cover artificial intelligence and kind of how this affects auto safety. They're fun. They're about a half hour each, so enjoy. You're listening to There Ought to Be a Law, the Center for Auto Safety podcast with Executive Director Michael Brooks, Chief Engineer Fred Perkins, and hosted by me, Anthony Simino. For over 50 years, the Center for Auto Safety has worked to make cars safer. Hey, listeners, welcome to the show. We've got returning guest, fan favorite, Phil Koopman, coming back, and he's going to explain to us all about artificial intelligence and safety with automated vehicles.
Or at least I'm going to try. Thanks for having me back.
Perfect. We're going to try and come up with decent questions. So just before we started, I was saying my big motivation for this is that everyone hears constantly that artificial intelligence, it's smarter than a human already. I'd rather trust a computer to drive a car than a human. They forget the part that, it was those pesky humans who programmed the computers that are now driving the car, and people make mistakes. Doesn't matter where they are in the equation.
And they also forget that computers make mistakes that are inhuman. And they balance out. They don't drive drunk, but sometimes they drive pretty darn clueless. So there's a balance there. No one knows which way that balance is going to go.
Right. So people always apply anything they see on a computer screen as it must be true. They kind of anthropomorphize.
Have they actually used a computer?
Right. But I mean, I've had the issue with like my credit agencies think I was born 10 years after I actually was born. My name is different. I work in a casino. But people say it's on a computer screen. It has to be true.
All right. We're going to have a little fun. Very brief story. I tried to check into a hotel room made through an online agency once, and I couldn't find my room. I'm a junior, it turns out. Don't ever name your kid a junior. Because I was named before all this computer stuff was happening, right? And so I finally found the room. It was booked with last name JR. Because the computer just said the last thing must be the last name, and my last name must be a middle name. And it's like, there's all sorts of ways this stuff goes wrong for things that the people who designed the system just didn't think of.
Exactly. And that's what we see with artificial intelligence. We see the common examples of being ChatGPT and these large language models hallucinating things and literally making things up out of whole cloth, which is a very human thing to do, which I think is amazing. But then we apply it into cars and people are like, well, people drive poorly. Let's let the computer do it, which strikes us as a little dangerous. What do you think?
Well, the argument is people make mistakes, therefore computers will be perfect. And as I've already said, they must not be paying attention.
Right. So you've got a book coming out in the coming months. Fair to say?
Yeah, hopefully in September we're going to see. All this news keeps happening, and I keep having to spend time on other stuff. But I want to get back and finish the editing cycles, and it's getting there. I mean, as you guys have seen the table of contents. It's a real book. I just have to whip it into shape so other folks can look at it and hopefully benefit from it.
Great. And it's called Embodied AI Safety. What does that mean?
Well, embedded is this thing that everyone thinks is old, so people keep coming up with new names for it. I've done embedded systems since I was an undergrad in college. Okay, my first embedded system was a hotel control system on an Atari 1200. And if anyone in the audience even knows what that is, congratulations on being old.
That's not nice. I know what that
is. Anthony says he resembles that remark. Okay.
Yes. I was jealous when I had my Timex Sinclair Z80.
There you go. Well, I had the big show, but it was automating a hotel. And embedded was hot for a while. And then it became a little less hot, but then cyber physical systems became hot because if you call it a new name, you can get a new round of funding from the government, is what it turns out. I apologize. I'm slightly cynical about this, but it turned out I've been doing it for years. But there's new funding, and they did some research, and there were some new angles. There's a lot of formalism that hadn't been there before, and that's fine. That's fine. And that's sort of just come and gone. And now, because now AI is the new hotness, and if I said embedded AI, people would think it's old. But if I say embodied AI, that's cool, right? So we're going to say it's embodied AI, and it brings to vision robots, right? It's AI with a body. Okay, it's like a humanoid robot, but in fact, it's embedded systems with AI. A self-driving car is a robot, meets all the definitions for a robot, right? But it's not a self-driving car book. It's a book about if you want to put machine learning based AI, because that's what people. Oh, by the way, back in the early 80s, when I took a course in AI, it had nothing to do with machine learning. But AI these days means machine learning. So if you put machine learning in an embedded system, what do you do about safety? And so embodied AI safety is really to answer that question. And we can learn a ton from what the robotaxi folks have gone through. But that stuff, those lessons apply way past robotaxis. And so the idea is to use robotaxis as a platform and say, here are the things you really need to know. And then here are the lessons we can learn. And here's how the robotaxi guys did and didn't learn the lessons. But also, these are general lessons. They apply to anything that's going to have AI in it.
Okay. So let's take a step back for a second, because people hear artificial intelligence, that term. The computers are smart. The computers are thinking. So just very quickly,
not thinking, but okay.
Yeah. So that's the thing is I know, and that the term artificial intelligence is a misnomer that unfortunately somebody put out there in the 1950s, and they're like immediately regretted it. Are artificial intelligence machines, are they intelligent? And let's not get into the whole what is intelligence thing. But
well, it depends what you mean by intelligence.
Yeah.
And the thing is, if you can fake it, doesn't matter. And the answer is what you're trying to do with it. There was a program called ELIZA way back. And ELIZA was pretending to be, it was a chatbot. And it was spooky good. It could convince some number of people that it was a person chatting to it, but it was just a bunch of linguistic hacks. And I remember back when I was an undergrad, that it was fun playing with ELIZA. It was a blast, but it wasn't smart. If you beat on it a little bit, you could trick it into saying all sorts of bizarre stuff. You can find out quickly. But people who weren't sophisticated about the technology or didn't have good critical thinking skills would get sucked in. And what's happening today is that on steroids. So is it useful is a different question than is it intelligent? It's not intelligent by any definition of the word I'm comfortable with. It's a lot of statistics, especially large language models are gathering statistics in language, and they can synthesize text that is extremely plausible because that has the same statistical distribution of things it's trained on. And for things where factual accuracy doesn't matter, it can do really interesting things. And so if you're trying to write fiction, it can generate fiction. I personally think what it produces is kind of soulless, but it can put out plausible sentences. If you're trying to write an email and you're not a polite person, but you want to fake being a polite person, and this person has done something to irritate you, and you want a very polite email to explain to them how to stop irritating you, it can really help with stuff like that. But you have to be careful because it's just making stuff up. And factual accuracy really doesn't enter into it. So there's some things. So if you're doing social interaction, maybe that's fine. If you're trying to say, I want the answer to a very sophisticated technical problem, and it's not a problem that's been solved a bunch of times before, so it can just parrot back answers, you're going to have trouble. Now, there's a lot of hacks. There's a lot of ways. And between the time this is recorded and it plays, someone will come out with 10 more ways to make this stuff better. But ultimately, it's producing statistically plausible things that the statistics are based in what it trained on, but it doesn't actually have a notion of what truth is. It knows it's sort of like the stuff I trained on, but that's a little bit different than knowing truth. So So what's that saying? The key to success is sincerity. If you can fake it, you got it made. That applies to LLMs, right? They're really good at faking sincerity.
Yeah. So they have no understanding of what they're putting back to you. It's very simply
not understanding in a deep sense.
Yes. Yeah. Okay.
They have some statistical notions of internal consistency, but that's different than understanding.
That's totally different. Okay.
So if you can fake understanding, you got it made. I did the setup and I did the callback. Okay.
That was perfect. Great. Yeah. So they're essentially zombies. But when we get into, robotaxis and self-driving cars and advanced systems, do they, for the AI use there for, we'll say, like object detection, where they can see there's some sort of object that's crossing in front of the vehicle? You don't need understanding as we know it to get what it is. You need to know that this is an object. So,
well, you need more understanding than you might think.
Okay, please let us.
So first of all, LLM type technology is only just beginning to show up in self-driving cars.
Oh, is it actually showing up now? Are they?
It is. People are starting to use it. So Wabi wants to use that type of technology to do the training, to do training simulation.
Okay.
And other companies are talking about, and I'll just do the cartoon version because it's all over the place. But you could feed a camera image and say, "Should I turn left or right?" and let the LLM tell you which way to go.
Right.
And that's probably not a good idea at all. But there are more sophisticated things you do, and I don't want to get into the details here. But there are ways you could say, "Well, tell me what I'm looking at and where the objects are, and then put that into a path planner." Maybe that's the kind of things people think about. But how that's going to work, I'm not sure. That's early. If you got on the road today and look at a Waymo robotaxi, or at least as far as we know, or even a Tesla robotaxi, because those are out as of yesterday as we record this.
Right.
My understanding with all those is they're not using LLMs, large language models, to say, "Well, tell me what's going on. I'm going to feed that somewhere else." They're using end-to-end machine learning or componentized machine learning, and without getting into the difference between the two, the idea is you put a bunch of data in and it trains on the data you show it, not on every text it can scrape off the web, licit and illicit. It trains off stuff you actually feed it much data, you train it, and it will, for example, in the case of a componentized one, there's a perception box, and you say, "This is a person, this is a dog, this is a vehicle, this is a shadow," and you train it on recognizing, "Yep, that's a person, that's a dog, that's a vehicle, that's a shadow," and then you throw in camera images and steering commands come out. And somewhere in there, there's something about, you probably shouldn't hit that because it smells like something you shouldn't hit. But in both cases, the componentized one is easier to talk about. In a componentized one, you'll show it 1,000 people, 10,000 people, 1,000,000 people, and it'll get really good, scary good, creepily good, almost like it understands, but here's the catch, that's a person. But if you show it a kind of person it's never seen before, it just makes a wild guess. It's usually pretty bad at knowing that it's like, "I haven't seen that before." That's their Achilles heel. But the important thing is you say, "Is that a person?" And it'll say yes or no, but it's not actually answering the question you think it's answering. If it says that's a person, it doesn't actually know what a person is even, not really. What it's saying is that is statistically similar to all the things I trained on that you said were people.
Right.
Which is different than that's a person. It sort of smells like a person, quacks like a duck, walks like a duck, looks like a duck, must be a duck. For practical purposes, that's a pretty good approach. But it's different than actually knowing what a duck is or what a person is. There's a little bit differently. It's a similarity function as opposed to a deep understanding.
Okay.
So how do you engineer a vehicle when you know that there's not a one-to-one correspondence between the machine's understanding of reality and the human understanding?
Well, lots of folks just ignore that difference and call it a day. Let's say we trained on people, we trained on vehicles, we're good to go. And where that shows up is the edge cases. There'll be a thing that's a person that this is earlier technology, but we found that people dressed in yellow weren't people. because it hadn't trained on people dressed in yellow, and it wasn't sure quite what they were, but they weren't people because people aren't wearing yellow raincoats or yellow construction vests because they didn't train in construction areas and they didn't train in the rain, and so they never saw that kind of thing. And so what you get is weird, really counterintuitive holes in the performance. And the issue you get is that when people engineer these things, especially for safety, and they anthropomorphize them, which everyone does, that's a human tendency. If you anthropomorphize it, you're projecting on it things you think would be hard and things you would think would be easy. And what you're not neglecting is the things it's going to make a mistake on because it never occurred to you it would have trained weirdly. And there's a great example. There was a Waymo crash. Last I checked, they would say they had no injury single vehicle crashes or no occupied single, but they had a single vehicle crash without a person in it, smacked into a utility pole. And the reason for it was it had been okay, I'm anthropomorphizing, but it had been programmed that utility poles were okay to hit. Now that sounds weird, but if there's a blade of grass sticking up out of a crack, you have to the robotaxi, it's okay to hit that. Otherwise, it's going to stop for every blade of grass, right? There are things that are okay to hit for sure. And somebody made a mistake for however it happened that utility poles were okay to hit. But why wasn't it discovered in testing? Well, curbs are not okay to hit. And this crash happened when it encountered a utility pole that was not protected by a surrounding curb. It was in a parking alley and there were no curbs, right? So and Cruise had one. They hit a 60-foot bus because they'd been taught that all buses were 40 feet, and it measured the back of the bus by looking at the front bumper and going 40 feet back and saying that must be where the back is, regardless. Even though the LiDAR saw the bus, it said, no, that's a false return because I know buses are only 40 feet long, so it smacked into it.
Wait, that's what happened with that case?
That's what that was, yeah.
Oh my God. I mean, so that was some very... that is wild because that was programmed to say, okay, buses are only this length.
Yeah.
Other systems in the car see that, hey, this is an object.
It's got the LiDAR, it's got the camera, it sees the object.
Radar.
No. That's I don't know what you're looking at, but it ain't the bus because the bus is only 40 feet long. Whack. Okay. And so this is tricky because people say these things. I was when I started, I was kind of wrong, but wrong in a really unexpected way. I always said that people make mistakes. They drive drunk. They're inattentive. They make stupid mistakes, right? And I said, computers will make different mistakes than humans, right? Because I knew that would something would happen, right? Like the Cruise dragging emergency scene tape and down power wires, dragging it down the road. That's something that you'd have to be pretty out of it to do that as a human driver, okay? But then we saw Cruises and Waymos both going into construction zones. We saw these cars getting stuck in cement, and people correctly said, well, humans do stupid stuff just like that. And crashing into a telephone pole, yep, people do that. Crashing into a bus, yep, people do that. So it isn't that sometimes they'll do different crashes, but many times they'll do crashes that look like a bad human driver, but they're doing it for extremely different reasons, fundamentally different reasons. And so computers fail differently than people. And it is because I think a lot of it is they lack the deep understanding, especially they're really, really bad at knowing they don't know. Because a person would say, I don't know what's going on. I'm going to slow down and figure this out. And they can reason from first principles what's probably going on for something new. Whereas a robotaxi is just, yeah, I'm supremely confident and it has no idea what it's doing.
Right. So I guess this would be a question more from Michael. So our whole legal framework, our safety framework has been based on humans. And what Phil was just saying, a typical human's going to be like, I don't know what to do here and I'm going to stop. Or if not, I'm going to be a maniac and do something dangerous. What do you do when a computer system does something that is not human-like? Is our legal system going to change to figure out what happened there?
Well, I hope so. I mean, we already see a lot of issues with the legal system just trying to adapt to level 2 vehicles. So when you get to truly autonomous vehicles, there's a long way to go. Even in Texas, where I think they just recently passed a new law that somewhat heightens the requirements for deploying autonomous vehicles in the state. There's still that struggle over they're having to modify their own state law to account for, who's responsible in a crash, who's responsible when there's a citation issued, and a lot of things like that. So the law is absolutely going to have to change, in all 50 states and federally, and in traffic law, in tort law, negligence, product liability. There's a lot of room for change. And I think that's going to, that's probably something that's going to extend well beyond just driverless cars and into a lot of the new interactions that humans are going to have with computers.
I think it's gonna be pretty bad if we try and fix it the hard way.
Yeah.
And I agree, Michael, that I look at it as anytime a computer supplants human agency, you're going to have problems if you blame the human who just got supplanted, right? And driving is just one of them. Now, I've had some work, as you know, but the listeners may not have heard this or not heard it recently, that I co-authored with William Wyden, a lawyer, on a bunch of this stuff. And I think we were both on his interview, so I'll give the short version. That was a while back. But you might want to point her to that old episode. And the short version we proposed is to avoid breaking the entire legal system and taking 20 years of case law that are going to be distorted who knows how by lobbying and all this other stuff. There's actually a pretty simple approach. You just say, well, everywhere it says driver, well, you have human drivers and you have computer drivers, and computer drivers are held to the same standard as human drivers. Even though computers can theoretically be better, you're using an existing mechanism to assess their behavior, their duty of care to others. If you run a red light and hit someone, we shouldn't be talking about product liability. You ran the red light. Why do we care which line of code was bad? You ran a red light. Aren't we kind of done? That's clearly the computer's fault. And this is like electronic signatures. For a while, nobody knew if those were really signatures or not. They said, everywhere it says signature, electronic counts. Okay. And so our proposal is everywhere it says driver, computer driver counts too. And since in some states, you can still throw a computer in jail for bad driving, but we hope those laws go away. Texas is making strides in that direction, but they're blaming the owner. And if the owner's Tesla or Waymo, sure. But if the owner's somebody who bought them like an Airbnb, they have no control over the driving code. Throwing them in jail ain't going to fix anything, right? And ultimately, it has to be the manufacturer. There's some subtleties who that is, but whichever corporate entity has the ability to fix software defects, and whoever does the remedies for recalls, they should be on the hook for tort liability if the thing drives like a crazy human drove.
So with these systems, are they set up in a way that they can figure out what happened? So the example you gave of the buses are 40 feet, not 60 feet. A lot of these machine learning systems, neural networks, it's a black box. We have inputs, we have outputs. We don't know what happened in the middle. Are any of these companies taking that approach from a safety engineering point of view to say, hey, can we backtrace and figure out why it thought buses are only 40 feet? Some of this, I imagine you have to guess, but.
Well, the new hotness here is end-to-end machine learning. Okay. And large language models are the thing beyond that. And so we're going away from transparency. The old componentized stuff we had, this is a perception box, and then you have a planning box, and then you have a prediction box. You have all these boxes. You can see if the box got it wrong because image goes in one end, list of objects comes out. Oh, that's a person. It misclassified it. There, it's actually easier to see what happened. And I think when Cruise had that crash, they're more that way. And Waymo, last I heard, is sort of that way. But when you go end to end, which is what the cool new kids are doing, okay? It's camera image comes in and left, right, fast, slow comes out. That's what Tesla FSD is these days, as far as I know, and I have pretty good info on that. And so if it makes mistakes, you have no idea why. Not really. I mean, there are techniques you can do to crawl back through the layers of end-to-end machine learning, but as a practical matter, I got it wrong. Train it some more so it doesn't get it wrong next time.
So is safety engineering still a thing? Like, I mean, if you can't figure out why something happened.
There are some folks who are being more clever about it. I can't speak specifically about it, but I published a paper before all this happened that said if you have end-to-end, you really want to split it in the middle and have a perception front end that tells you what it saw and a planning execution back end. exactly so you can diagnose, did it do the right thing for the right reason? So that's my favorite architecture. It's been my favorite architecture since 2017 or 2018 when I read that paper. Maybe we'll see it make a comeback. Who knows?
I'm rooting for it.
Yeah.
Michael, what did you have?
I'm rooting for that as well. It just seems insane to me to have a black box in the middle that there really is no ability to fix. We're used to being able to fix cars. And here it's like, well, we can give it some more training data and just hope for the best.
Well, I know we're kind of running towards the end. Let me make my last main point, and then you guys can pepper me with follow-ups. There's right now, Waymo, last I checked, did componentized, and I'm sure they and everyone else are looking at end-to-end because that's the thing. But componentized, you have these chunks of machine learning, and you glue them together with conventional software. And that makes it, there's a lot more labor intensive because you have folks writing software to glue it together, but it makes it very easy to put it in special cases, like no right turn on red, but only in New York City. Well,
Right.
That's a line of code. How do you train something with no lines of code about that rule, especially if none of its training data was in New York City, or if it is in New York City, how does it know that New York City was the thing that made it different? Who knows, right? Whereas end-to-end is literally camera images one end, left, right, fast, slow out the other, and the rest is just magic. Now, there actually is a bunch of engineering that goes into, especially using transformer technology with multiple heads that sort of fill in for these things. So it's a little less opaque than it sounds, but it gets pretty squishy. It gets pretty tenuous. It's kind of hard to manage what's really going on in there. And for safety validation, it's really painful. But what do I expect with these technologies? The dynamic I expect to see is for end-to-end, because there's not a lot of manual engineering, and because you can feed it just as much data as you want and not, because the component guys have to pay for every image to be labeled. Some human says, that's a car. Maybe they have some automated system, but ultimately some human says, yeah, that's a car. Yeah, that's a person. And then you just feed a bunch of data and let it figure it out, right? So my expectation is end-to-end machine learning like Tesla and like some of the truck folks is going to be much easier and potentially cheaper to get working pretty well. Because a small team can take a ton of data and get it to work pretty well. All right. So driving competence is easier with end-to-end. Driving 100 miles without running into something is going to be easier with end-to-end because you don't have these people doing all the special cases, right? However, safety isn't about the average case. Safety isn't about the first 100 miles. It's about the first 100 million miles. And so what I expect is the end-to-end is going to have much, much, much harder time dealing with the edge cases that live out past 100,000 or a million miles, which is where, it's one fatality per 100 million miles in round numbers. So fatality safety lives out in the hundreds of millions of miles, and end-to-end is really going to struggle because nobody has the machinery to train it on a billion miles, a few thousand miles, a few tens of thousand miles about, and you just run out of steam to hold all the stuff. Now you can be clever. You can curate the data you train it on to include a bunch of edge cases, but that's where the engineering shows up. So the engineering isn't writing lines of code as you do in the component. It's curating the training data to make sure it's seeing the stuff it needs to see. So you haven't gotten rid of the engineering effort, back to your question. What you've done is you've transformed it from a writing code thing to a collecting data, curating data thing, which is sort of a lot more indirect. And you're trying to steer this thing with a really loose coupling. You don't have a rigid pole to move the machine learning around. This is analogy, of course. You don't have a rigid pole to move it around and put it where you want it. You got this sort of like rubber hose that's flopping around. You're trying to steer it through a rubber hose. It's going to be tough. And so I expect companies using end-to-end machine learning will make impressive gains much more quickly than other teams. And they're going to spend, just to pick numbers, they're going to be 10 times quicker getting stuff on the road, and it's going to take them 10 times longer to get safe. Oh, boy.
All right, listeners, we're going to wrap this one up here. Next week, we're going to ask Phil why pretty well isn't good enough. As this just sounds like the steroids of software engineering. You're going to get great gains, but long-term, not going to work out well for you. And with that, we'll be back next week. But for us, it'll just be a minute.
Thanks. See you next week.
Bye.
For more information, visit www.autosafety.org.